Good day. With your permission, I present a work neural network method for parametric adaptation HelicoptersTurboshaft engines on board automatic control system parameters. At present, electronic digital automatic control systems have been intensively introduced which have higher accuracy and wide opportunities for optimizing of gas turbine engines controlling process. At the same time, much attention is paid to the development and research of intelligent algorithms for monitoring and diagnostic of the operational status of gas turbine engine automatic control system using neural network technologies. At the same time, due to a number of reasons, closeness of work, narrow specialization of the task being solved. Most publications lack theoretical and practical recommendation for solving the above problems, which leaves a wide field of activity for conducting scientific research in this direction. Currently, there are many research devoted to the development of automatic control systems, but there are no works in the field of helicopter technology. This determines the relevance of the proposed research aimed at creating adaptive algorithms for monitoring helicopters' turboshaft engine, which make it possible to identify engine parameters with high accuracy under conditions of external and internal interference. The helicopter's turboshaft engine closed on-board automatic control system was developed by this author's group and is shown in figure. Its modification consists in supplementing with modified software modules that implement adaptive control methods. In this work, using as a basis the results of Ivan Bakharev research for a ground-based gas turbine plant, we consider the addition of the developed automatic control system for helicopters turboshaft engine with a reference or custom model modular, a parametric adaptation modular. This slide presents a mathematical model of the parametric adaptation task, which consists in determining the simplest similarity criterion. In the process of helicopter's turboshaft engine monitoring, the parameters of all elements of a closed-loop change in real time. To ensure the desired behavior, it is necessary to dynamically compensate the free turbine speed controller and replace it with a controller of the same structure turned in the desired way. This figure presenting a dynamic compensation diagram. The input data for training the neural network are following parameters of helicopter turboshaft engine which are recorded on board the helicopter. For parametric adaptation, it is proposed to use speed neuroregulators, which are an antiphysical neural network. The most common and simplest version for speed neuroregulators, shown in figure, was chosen as this neural network architecture. As an assessment of the work of helicopter's turboshaft engine closed on-board automatic control system, an integral criterion of the form is adopted. This table shows a neural network training algorithm developed on the basis of the Nelder Mead method. The neural network of the perceptron architecture consists of two neurons in the hidden layer. This number is due to preliminary research that shows an acceptable quality of regulation with this architecture of the neural network. This slide shows the neural network training results. There are modulation characteristics convergence diagram, simplex characteristic number convergence diagram, transient process obtained as a result of the work of the neural network training algorithm, dependence of neural network, training error of the number of neurons in the hidden layer. Results of adaptation criterion calculation and results of training algorithm are presented in this slide. It has been proven that the best version of the neural network in the case of using the integral quadratic criterion in the neural network of the perceptron architecture with the sigmoid activation function of neurons. Slides 12 and 13 show the results of primary and secondary tests of the developed method of 4 engine parameters: frequency of free turbine rotation, gas generator rotor RPM, matter regulator integrator, free turbine regulator integrator. The tables show the percentage improvement with the adaptive controller compared to the standard controller. The results of comparative analysis are present in this slide. It has been proven that the use of parametric tuning unit with a customizable or reference model in HelicoptersTurboshaft engines closed onboard automatic control system improve the quality of recognition of transit process by an average of 30% compared to the use of standard regulators. The conclusions are present on this slide. Thanks for attention.